All right, so net change, when you're talking about position, you want to think of, all right, what's the rate of change of position? In this case, it's velocity. So if we want net change in position, this is going to be the integral of velocity. But the problem is we don't know what the velocity is. But that doesn't matter because we can figure it out because we're smart individuals. Well, most of us are smart. You guys are smart. I have moments. Just because I'm teaching it don't mean I'm smart. I'm sure you can say that about some teachers. None here. None at Sterling. Alright, so now I'm going to kind of cover this up, and velocity is equal to the integral of acceleration. And if I'm trying to figure out times dt, because everything's in terms of time. Now, if I want the function is going to be the indefinite integral with initial conditions. So I'm trying to figure out the function, so I'm going to take the negative 32 dt, the integral of the negative 32 dt. And that's not very bright at all. Like, I don't even know where my remote is. They don't let me have my prep. Everything goes to crazy. All right, what's the integral of negative 32? We know that. Plus c. So my velocity is equal to negative 32t plus c. Alright, but when t equals 0, what was my initial velocity? (96). So I know when I have v of 0, I've grown tired of that pen. This is where that kind of goes. But this is kind of what we did yesterday. But I wrote really big, so I ran out of space. But if you want to think of it like this, you do the integral of negative 32t dt. That's equal to negative 32t plus c, which is equal to velocity. I know v sub 0 is equal to what? 96. So I could say that 96 is equal to negative 32t plus c, but what's my t equal to? I heard it, 0. So 96 is equal to negative 32 times 0 plus c. What happens to that 0 here? All that stuff is 0, so what's my c? 96. So now I know my velocity. Velocity, and you are going to run out of a little bit of space here. So you might have to work somewhere a little. So v of t is equal to negative 32t plus 96. Now, net change in position is going to be the integral of velocity. So I'm going to try and work over here. What's my time? 0 to 6, and what my velocity is negative 32t plus 96, and that's going to be dt. So I'm going to get a t squared from here, aren't I? So I'll get negative 32 t squared over 2 plus 96t, and I need to evaluate this from 0 to 6. Now at this point you could dump it into a calculator. And I'm going to, because I have a lack of space, and a lack of other stuff too, but so negative 32 times 6 squared divided by 2 plus 96, what, times 2? No, times 6. Can't see anything at all, can you? Almost. What's it look like? 0. So I'm going to get 0 there for the first part at 6. Now when I plug in zeros, what's going to happen to everything? Make 0. Make 0. That doesn't sound right. Make 0. Never mind. There's a bad joke there. It was going in a bad direction, so I had to cut that joke right off. So, what's my net change in position? 0. So, if I looked at the ball at time 0, closed my eyes, waited for 6 seconds, and opened my eyes, where's the ball?
Same place.
Same place. Did it look like it moved at all? No. But the thing is, we have to figure out if it actually moved. But the idea of net change is, if you like close your eyes at the first time and then open them up afterwards, you're going to see that net change. What is that net change? And we call this, yep, we call this displacement. So we call that displacement. And in this case, it was nice because it went to 0. Or the displacement ended up being 0. Which means it went somewhere, but we don't know what it was. Now, the total distance traveled. This is just a little bit different than what we had before. This is going to be equal to the integral from t1 to t2 of the absolute value of the velocity dt. And this is where it gets kind of crazy. Now, here is the easiest way to think about this. What's my velocity equation? Alright, there's nothing up there. So negative 32t plus 96. Looks bad, I know. Now, in order to figure this out, basically what we want is, we want all the regions where the graph, bless you, is going to be positive. And then when it's negative, we want to take the opposite of it to make it positive. Because you can have a graph that does this. Over here is a negative, right? If this is the velocity function, for whatever reason this is my velocity function, and over here, these are going to cancel each other out. Or maybe they cancel each other out, but at least I'm going to have a positive. That kind of means it's moving to the right, or it's moving up. This is negative. That means it's moving to the left. Now, the difference between the two is your displacement. So it takes into account when there's a positive region and there's a negative region. But what I really want is, I want to say, well, you know what? I don't want that negative, I want to make it positive. So I really want this part of it, which is equal to that whole thing. So this part, I want to kind of move it up here. So what do I do? How do you make a negative into a positive? Absolute value, which is what we're doing, but realistically, we don't have any integration tools for absolute values. So Navila, what were you saying? You multiply by a negative 1, right? That's what you were getting at, right? You multiply it by a negative 1. So if this is f of x, this is going to be negative f of x. And that's what we want to do. But the trouble is, we got to find the regions where that area would be negative. And so we have to take this equation and we have to use the sign test on this guy. And here's how you do it. You take the equation and you set it equal to 0. So negative 32t, or I don't know why I can't write it. It's beginning to really annoy me. But life continues. So I get negative 32t plus 96. Solve this for t. Subtract to 96, subtract to 96. So I get negative 96 is equal to negative 32t. Divide that by negative 32, negative 32. What's my t equal to? 3. So at 3 seconds, my velocity is what? Yeah, at t equals 3, velocity equals 0. What does that mean? Well, it's not moving, but okay, graphically speaking, or calculusly speaking, it's got a maximum. But if I take a ball and I throw it in the air, where it's not gaining any more height. So where's it at? It's at its top value. So it's at the top. So it's where it changes directions. That's what we look at with maxims, right? When we change directions. So if it's going up, then going down, and we found out at t equals 3 the velocity was 0, it's changing directions. It's from going from a positive maybe to a negative. Does that kind of make sense? So the velocity stops, becomes 0, and then it changes at that point. Well, let's see what happens on either side of 0, or on either side of 3. So I'm going to take 1 as a test point. Plug in 1 into the equation. 1 times negative 32 plus 96. Is this positive or negative? Positive. I know it's 0 here. And take a test point of 4. Now this is going to be a little bit more than 120, right? It's like negative 128-ish. Actually, I think it is a negative 128. So if it's negative 128 at this point, negative 128 plus 96 is negative. So this is telling me that it's got a maximum right up there. Or that if I'm talking about the position function, it's got a maximum at 3. So where is the velocity positive? If I'm looking from 0 all the way to 6, 0 to 3, v of t is positive. Here, v of t is negative. Now, This is how you set up. I'm going from 0 to 6, and I want the absolute value of negative 32t plus 96 dt. Now what I'm going to do is, based on this idea where I find out where the velocity is positive and negative, I'm going to break this up into two integrals. I'm going to say from 0 to 3, and then from 3 to 6. Now, is the velocity positive or negative here? Positive. So I'm just going to take the regular old velocity equation, 32t plus 96 dt. Now, from 0, since v of t is greater than 0 here, so it's positive here. It's negative here. What do I do to make it positive? Multiply it by negative 1. So I want negative 1 times negative 32t plus 96 dt. And this negative 1 makes this positive, because if I want to figure out how much I've actually traveled, I don't care if I went left or right, up or down. I just want to know my distances. So if it was a negative distance, instead of saying, all right, let's say that way is positive. So if I went like this, took 7 steps here, I started at 0, I went to 7, then I went back 4, I'm at 3 now, right? My displacement was 3, because I only, if you closed your eyes after I started, didn't see what I did, didn't see how I walked or moved at all, ended up at 3. The total displacement was just 3. I just moved 3 spaces. But how much did I actually do? Actually, I went 7 over here, which is a positive 7. I went negative 4, which just told me I went in this direction, but I don't care about the negative. So it was 4, so I went a total of 11 spaces. That's what we're trying to do. We're trying to get rid of that negative sign that's in front of the negative movement and make it positive. So when we're talking about total distance, that's what we have to do, and that's what you guys have to do. You got to figure out where is it negative, which is going to involve a sign test. And then after that, we integrate. I'll let you guys integrate that. I think it's 104 or 288. Now, if you have this super special calculator, or actually, I don't think you might not need the super special calculator. You might be able to use the less than super special calculator. Use an extension cord that's 40,000 feet too long. Alright, the only reason why is because the battery on here is a piece of junk, or there's a short inside of the calculator. I don't know why, but it has to be plugged in for it to work. Alright, so doesn't help at all. Alright, if you don't have an Inspire with you, go grab one. Because you can use this on the test. Alright, there's a good spot. I can actually put this over here too. Alright, now you're going to want a calculator. You don't want Scratchpad. Scratchpad's evil. You don't ever want to use it. Scratchpad doesn't have any of the characteristics that a regular calculator has. Well, it has a lot less anyway. Now, if you go right next to the 9, where it has a bunch of the templates, so the button next to the 9, there should be an integral right here. So there's an integral. So you can hit this, and it's going to give you an indefinite integral. So what are my bounds? 0 to 3. My first bounds are 0 to 3. And now I'm just going to type in the formula. Negative 32, was it negative 32? We'll go x. Was it plus 96? And then what's the d? dx. Alright, so now I got to get out of there, and I want to add on another integral, don't I? Alright, so I add on another integral. There's right by the button left to the or right to the right of the 9, it has all the templates, and the integral is in the third row, second button. All right, so what are the limits for this guy? 3 to 6, because that's the next time the function's that's when the function's negative. So I need a negative 1 times. Now I'm going to type in negative 32x plus 96, and then close up my parentheses, and then put dx, and then squint and brace for impact. Hit there. Oh, 288. Woo! That's what the answer should be. Because I've done this before. I know what the answer should be. So it does give you the answer, so you can just type it in and go, which is nice. Now, you could have done this by hand really easy because they weren't big numbers. You would have had like 6 squared times 32 divided by 2, 16 times 36. All right, maybe it would have been a big number, but it's not that big a number. You could multiply 32 times 30 times 16. But it's nice to know that your calculator will do this. And this is even though it's the color version of it, it's the base model. It's not the computer algebra system model. The computer algebra system model is cool because it'll do the indefinite integral for you. Which means whenever we have the stuff plus c, it'll actually do that for you. So now, when we talk about total distance traveled, we have to account for the fact that sometimes the equation, the velocity equation is going to give us a positive area, and that area is going to represent your movement in the positive direction, and sometimes it's going to give you a negative. So you're going to have to break up the integral into different parts and make sure that the positive is positive, and the negative gets turned into a positive. So this is the only time that you get to change the value in the integral. Because normally when we're doing stuff, when we're doing u substitution, we can't change it, so we have to multiply by 1, like 6 over 6 that we've done, or the 2 over 2, all that kind of stuff. This is the only time you get to change it, when you get to multiply by that negative 1. Alright, I want you to try the second one. A particle moves along a line with a velocity of t squared minus t minus 6. I'll give you some time to work on that. And it asks for the graph. You can use your calculator for that if you like. Then find the displacement of the particle, and then find the distance traveled. So it's I'll be honest, it's basically doing the same thing that we did above. Now you get to do it by yourself to see if you can figure it out.